Hello, today we are going to be covering the properties of logarithms, otherwise known as logs, and you guys will be able to use these properties of logarithms. So our first property is the product or multiplication. You'll notice here that you have log base b of m times n. This is what you're looking for when we talk about product. Now, if you have a product with a logarithm, you can actually split it into two separate logs with m and n separated. So, for example, if you have log base 3 of 7 times x, that is equivalent to saying log base 3 of 7 plus log base 3 of x. Quotient rule works similarly. These are kind of like our exponent rules, honestly. If you have log base b of m over n, this is equivalent to log base b of m minus log base b of n. So, for example, if you have log base 3 of x over 7, this is equivalent to log base 3 of x minus log base 3 of 7. Okay? Now, if we have a power, you're looking for an exponent here. That exponent can actually come to the front. Notice how n becomes in front of the log, and they are multiplied. So, for example, if you have log base 3 of x to the 7, this is equivalent to 7 times log base 3 of x. And then change of base, you'll notice you have your big number is on top here, and your base is on bottom. This is changing the base, and you can actually just solve for a number here. So if you have log base 3 of 7, this is equivalent to a log of 7 divided by a log of 3, and that is about 1.77 when you plug that into a calculator. Okay, so we are going to work on expanding as we did here, and then we will condense, which is working backwards, okay? So, first of all, decide what you have to work with. So I first notice this division. Okay, it's kind of like our PEMDAS, where these two can be interchangeably used, and then we are working down the scale. And then when we try to condense, we work up the scale. But we'll get to that, okay? So IC division, we have the same base of 6 for both of them. So we have a log of 6, log base 6 of 5x cubed is subtracted by a log base 6 of y. From here, I'm highlighting what I see. I see multiplication. So I'm going to split this one apart. So I have log base 6 of 5 plus log base 6 of x cubed minus log base 6 of y. Don't forget that one. And then from here, I see an exponent, and that exponent comes to the front. So I have log base 6 of 5 plus 3 log base 6 of x minus a log base 6 of y. And that is actually our expanded notation. You could also work backwards and get back to this original, which we will do in a little bit, something similar to that. But this is your expansion here, your solution. Okay? Let's do another expansion. This one's actually a little easier because there's less IC multiplication to start, which means I'm going to have log base 5 of 3 plus a log base 5 of x to the 4th. I see an exponent here, so that needs to come down. So we have log base 5 of 3 plus 4 log base 5 of x, and that is actually our expanded. Probably wouldn't hurt to go ahead and just show that multiplication between there, although you wouldn't necessarily have to. This is our solution. Okay? Now we can also condense our logarithms. So I see addition, that means I'm going to have multiplication. I see a number out front, that means it's going to become an exponent. I'm actually going to start with that. I see this number out front, I know it becomes an exponent. Maybe I should fix these arrows a little bit. Whoop, right there and right there. So we're going to have log base 2 of x to the 6th power plus log base 2 of y to the 5th power. Notice the bases are the same thing. So that's good. Okay? Now, because we have addition here, that means these are going to end up being multiplied. Log base 2's are the same, so we just have log base 2 of x to the 6th, y to the 5th, and that is our condensed form. Okay? Now, I did briefly mention this earlier. If there is no small base number like we have here, just a plain old logarithm is actually equivalent to log base 10. Just keep that in mind, okay? Now, I need to look. I'm working backwards now. I'm looking for an exponent to start, and then I'm deciding addition or subtraction. I see that this will become an exponent. So I'm going to go ahead and do that. So I have log base 9 plus log, oh sorry, not log base 9, log base 10 of 9 and log base 10 of x to the 3rd. And you can just say it actually log of 4. You don't have to say base 10 since it doesn't have that on there. Okay, so now I see addition. This signifies that I'm actually going to multiply. So I have log of 9x cubed minus log of 4. Notice they're still both base 10. Means we can keep condensing. And then when I see subtraction, I know I'm going to divide. So we have log of 9x cubed over 4 is our simplification. All right. And then we are going to use the change of base, which we haven't used yet, to find the value of the following. Now this is just as simple as plugging it into our calculator. But we have to remember what goes in the numerator and the denominator. So this number, the big numbers are numerator, our base is going to be our denominator. It's not just the numbers though, it's a log of 27 over a log of 81. These are base 10 ones, that doesn't really matter too much. Most calculators will want you to just plug it in as a base 10 logarithm. So log base 10 or log of 27 divided by log of 81. We can go over here to our scientific calculator. So we have log of 27, close my parentheses, and divided by a log of 81. And we have our solution is 0.75 or 3/4, whichever way you want to write it. And that's our change of base formula. It tells us what our solution is. All right. And then we can do the same thing here. So we have log of 36 over log of 5 is equal to, go back to your scientific calculator. I'm actually just going to back up and plug them in here. Log of 36, log of 5, we get 2.23 approximately. I'm going to go ahead and do this. So instead of using our normal exponents and switching it to what we did previously, where this would be 5 to the question mark equals 36, and we tried to think through it. We just already know, based on the change of base formula, that would be what our exponent is. So it makes it a little easier to solve for the exponent, or just the solution for log base 5 of 36. Have a great afternoon.